Hey, Red Devil Chemist, how's it going? It's Coach Scott here with Red Devil Chemistry, and we're working worksheet 4S, right? And now we're going to look at problem 15. So join me on this one here real quick, and let's see what it is. So I'm reading it. A compound contains 48.65% carbon, 8.108% hydrogen, and the remainder oxygen. So I got CH and O. Didn't give me the percentage of oxygen. Oh, but I'm smart. I know that if I total everything up of a total, I'm going to get all the percentages. I'm going to get 100%. All right, 100%. So if I total up the carbon, 48.65, with the hydrogen 8.108, and assume those are grams. Oh, got to turn on my calculator. 48.65 plus 8.108, and I subtract these from 100, I'm going to get 43.242%, and that would be the percentage of oxygen. So now I'm going to write these, do our little, let's write CH and O. So I'm going to write our little table here, right? We're just going to do this problem because this could be a little something to understand. So I'm going to write 48.65, and I'm going to call those grams. Then I'm going to write 8.108 for grams. And then again, if I add those two up and I subtract from 100, I'm going to get 43.242%. All right, now we're going to go ahead and assume that these is a 100-gram sample. So now, what do I have to do? Oh yes, I've got to put the molecular mass or the atomic masses in. All right, let's go ahead and do it like this. All right, so the atomic mass of carbon is 12.011. The atomic mass of hydrogen is 1.0079. And the atomic mass of oxygen is 16. So just like before, if I divide those through, all right, if I divide the mass, which we're assuming is out of 100 for the sample, by the atomic masses, all right, the molar masses, if you would, I'm going to get the number of moles that are there, 48. So I get 48.65 divided by 12.011. I'm going to get a number of moles as, let's see, 4.05 moles. 0.5. All right, if I take 8.108 and I divide by 1.0079, that should be around 8, and guess what? It is. So we'll call that 8.00. Then if I divide the amount of oxygen, 43.242 grams, divided by 16 for the atomic mass, I get 2.7. I can't really round that or anything. Okay, so now I need to divide through by the lowest amount, 2.7. So if I divide through, and the lowest number of moles is oxygen. So now if we divide everything there by 2.7, and 2.7, that's going to give me, let's see, oxygen will have 1. All right, so 8.04 divided by 2.7. Right there, I got 3. Rounded everything. I got 2.975. That's going to round up to 3. So let's check 4.05 divided by 2.07. Oh, excuse me. 4.05 divided by 2.7. I get 1.5. I can't really round that. That's not even close. But what I do have to do, okay, is make this a whole number. if I have a 1.5 to make that a whole number, I need to multiply that through by 2. And if I do that, that's going to give me 3 moles. All right. And then if I do that one, it means I got to do that one. By the way, shout out to all my Irish friends. Garage. 2 times 3 is 6. And then if I do it to these two, I got to do it to that. So 2 times 1 is 2. All right. So what is it asking? The empirical formula? Yeah, let's go ahead and do that one. So the empirical formula, if I put these up there like that, C3H6O2. That is the lowest whole number ratio. That would be the empirical formula. So it gave me the molecular mass, okay, of 74.0 grams. Let's write that down so we have it. Molecular mass equal 74.00 grams per mole. All right. So we've got to get the empirical formula mass. Empirical, I can't spell, formula mass. Mass is equal to, so I've got to do like we have been doing, 12.011 times 3, because I have 3 carbons and they have a mass of 12.001. Then I need to add that to 6 hydrogens, which will be 6 times 1.0079 plus 2 oxygens, which will be 2 times 16, and I get a mass of 74.08 grams. 74.08 grams. If I take 74, the molecular mass, and I divide it by 74.08, 74.08 grams, I want to get pretty much 1. So that tells me that the empirical formula is C3H6O2, and it also tells me, because I don't have to do any manipulation with another whole number to get that right, that the molecular formula is also C3H6O2. So guys, that is problem number 15. Problem number 15. Let's see if we can, oh yeah, we're going to wait on 16 because there's a lot of work to that. So we'll do that in another video, which is coming up shortly. So this is Coach Scott saying, Red Devils, have a good evening.